Hi, I'm Robert Coleman. I'm a Senior Applications Manager at Texas Instruments. Welcome to Power Tips. Welcome to Power Tip 37. In this Power Tip, we're going to take a look at the rectifiers in an offline power supply and the impact of the selection of the capacitor on the power supply requirements. In offline power supplies, there's typically two types of rectifiers that are used. The first one is a full-weight bridge rectifier, as shown in our little schematic over here on the right of the slide. So it consists of 4 diodes, and as the input voltage is applied to the circuit, when the input voltage exceeds the voltage on the capacitor, the diodes conduct, and it'll conduct over this period here. And then at some point, the input voltage is going to fall below the capacitor voltage, and the capacitor itself will hold up the input voltage. And so you can imagine the slope of this line changes as the value of the capacitor changes. And then that also changes the conduction angle. For instance, if you had a smaller capacitor in your circuit, it would discharge more, and you would end up having to operate with a lower input voltage. A larger cap reduces the range that your power supply has to operate over. And that's important because that sets the turns ratio in the transformer, and it sets many of the circuit stresses. The higher that the input voltage needs to be for the power supply to operate, the more efficient the power supply is. This is the second rectifier configuration that's used in an offline supply. This is called a voltage doubler. And in the voltage doubler, what we do is we split the input capacitors, and we feed the neutral of the power source into the connection between the capacitors, and then we rectify a positive portion of the input voltage, and we rectify a negative portion of the input voltage. Now, what I've done in this drawing is I've shown the previous diodes also, and what people do in offline power supplies is if they jumper the neutral to the center tap of these capacitors, they can create a voltage doubler very simply. This works great because it allows you to reduce the operating range of your power supply. With a doubler, you can take a 120 volt input and make a similar voltage as you would to a 220 volt input full wave. And so that's how this is accomplished with a simple jumper here. The only downside to this connection is if the jumper gets installed in a 220 volt application, and now you may make 600 volt rectified voltage for your power supply, and it may create some problems for your power supply. So I've done a couple simple charts here to show the impact of the value of the capacitance versus the minimum range that you have to operate over, or basically the change in voltage on that cap at several different line conditions. So what I've done is I have normalized the value of the capacitance by the output power of the power supply. You know, for instance, if you had a 5 microfarad input cap and you're only putting 1 watt out of the power supply, you would end up over here on the curve on 5. And so I've done various configurations of the input capacitors here. I've done an 85 volt input AC that you might see in Japan. I've done a 216 volt input that you might see in Europe. And then I've done a 108 volt input like you might see low line in the US, and plotted capacitances versus the change in capacitor voltage at low line. And so the larger that you can make the capacitor, the smaller the change in voltage on the cap is, and the more efficient the power supply will be. And you can see that a typical value of capacitance that you might be working with is in the range of 2 to 3 microfarads per watt. The second chart takes our normalized capacitance for output power and looks at how much ripple current is in the capacitor. And so what we've done here is we've shown a variation of about 5 to 1 in the capacitance on the power supply and plotted on the left side the ripple current. And you can see that the value of the capacitance doesn't have a significant impact on the ripple current. That's because the current in the capacitor is pretty much going straight to the power supply during most of the cycle. You just encounter a small charging current, and that's the only thing that really varies. So hopefully you find these two charts useful. For some more power tips, go to Power Management Design Line and search Power Tips, or click on the link to all articles in the description section of this video. Thanks for your attention.